Good morning, dear students. We are discussing Unit 5 of Inorganic Chemistry, and our today's topic is phosphonitrile halides having formula PnCl2 whole n, where n is equal to 3 or 4. Phosphogenes and cyclophosphogenes comprises the phosphonitrile halides. These phosphogenes, they refer to a class of organophosphorus compounds with phosphorus atom in the oxidation state of +5, whereas nitrogen is in the oxidation state of +3. These compounds are formally unsaturated and these are also superbases. These may be cyclic compounds or chain polymers having N double bond PR2 as the repeating structural unit. So among the different phosphogenes and cyclophosphogen, we are having cyclic trimer having N double bond PR2 repeated thrice in a cyclic way and is known as cyclic trimer. It is having formula NPR2 whole thrice. Moreover, cyclic tetramer having formula N double bond PR2 repeated 4 times in a cyclic way, and these first two are cyclic analogs, whereas the last one is a linear chain polymer with formula N double bond PR2 n times. So it is a long chain. So moreover, beside this chain polymer, we are having a number of other chain phosphogenes are possible. These ranges from short chains, that is first one having formula P2NCl7, next P3N2Cl9, and it ranges up to 10 raised to power 4 unit of N double bond PCl2, which are linked together in a chain and forming a chain polymer of phosphogene. These compounds were originally called as phosphonitrile halides, but now these are systematically named as polychlorophosphogenes, as these contain many chloroatoms in them. So these were these were the chain compounds or linear chain compounds. These can also be cyclizes and form ring structure, and those ring structures are called as chlorocyclophosphogenes. These chlorocyclophosphogenes are the cycloderivatives of chlorophosphogenes. Among the chlorophosphogenes, our interest is in two compounds, that is hexachlorocyclotriphosphogenes having formula NPCl2 whole thrice. Here the value of N is 3, which is inversely by. And the second compound of our interest is octachlorocyclotetraphosphogene. It is an 8-membered cyclophosphogene. It is having formula NPCl2 whole 4. Here the value of N is 4, which is also included in our syllabus. And our interest is only in these two compounds with N is equal to 3 and N equal to 4. The first and the foremost thing that we have to discuss is their preparation, how these chlorocyclophosphogenes can be prepared. So as can be seen in the reaction, what we are taking many moles of phosphorus pentachloride. We are reacting it with ammonium chloride at 120 to 150 degrees Celsius in the presence of a chlorinating reagent like chlorobenzene, etc. And we get a mixture of ring compound of formula NPCl2 whole n, and we also get some linear chains, short linear chains phosphogenes as well. In case of ring compounds, the most predominant species are those having N equal to 3, that is cyclic trimer and cyclic tetramer, with n equal to 4. These two cyclic analog, these can be readily separated by distillation under reduced pressure. How? Since this NpCl2 whole thrice, which is cyclic trimer, it undergoes sublimation in vacuum at 50 degrees Celsius as a white crystalline solid, whereas the second analog, that is tetramer, and having n equal to 4, it does not undergo sublimation, and since these can be easily separated from each other. It's the simplest way of preparation of the cyclic phosphazine. Now their structure. This trimer, which is a 6-membered ring, and tetramer, their structure has been shown in the figure below. One is in black and another is in blue. The first one, that is the 6-membered ring, is planar, whereas the second one, that is the octachlorocyclotetraphosphazine, is puckered ring. And for this cyclic tetramer, that is NpCl2 whole 4, we are having two conformation of the ring, which is shown along the side diagram. The first one is the metastable form, which is having a saddle conformation, whereas the second one, which is shown below, is a stable conformation, and it adopts a chair conformation. Moreover, this cyclic trimer with the value of n equal to 3, it also exists as a resonance structure as shown in the figure. Now the properties of chlorophosphazines. This chlorophosphazine, first one, that is NpCl2 whole thrice, it is the key material for the synthesis of number of linear polymers. Here, the chlorine atom of these two, cyclic trimer and cyclic tetramer, they readily undergoes nucleophilic substitution. Means the chlorine atom of this cyclic trimer and cyclic tetramer can be replaced by some other nucleophilic reagent. For example, we can replace the chlorine NpCl2, the chlorine of this species, with fluorine using NaF, and in the product we can see that the chlorine got replaced by the fluorine. In the second reaction, we can also replace this chlorine by an alkyl group using Grignard reagent. Similarly, this chlorine can also be replaced by substituted by SCN. And finally, we can replace this chlorine by OR using sodium alkoxide, NaOR. We can also replace this chlorine with phenyl group, also using LiPH. The mechanism for the replacement of chlorine by this nucleophile is not well understood. However, it appears to involve SN2 attack on phosphorus atom by an anion. So there seems two substitution pathways. If the group that enters first decreases the electron density on the phosphorus center, for example, F replacing Cl, F is causing the decrease in the electron density on the phosphorus center of these trimer and tetramer, then the second incoming nucleophile or the second substitution will occur at the same phosphorus atom. So this is the case 1. What is happening? If the incoming nucleophile decreases the electron density on the phosphorus atom, then the second substitution will take place on the same phosphorus atom. However, if the electron density gets increased by the incoming nucleophile, then the second substitution will occur at a different phosphorus center. The last part of this topic is the uses of phosphazines. These phosphazines have many potential uses. They can be used as rigid plastic. Moreover, they can be used as expanded foam and fibers, since these phosphazines are waterproof and even fireproof, and these are also unaffected by the petrol, oil, or even acids. Moreover, these phosphazines, they also form flexible plastics which are useful for fuel hoses and gasket, since they retain their elasticity at low temperature. These phosphazines, these are at present too expensive for general use. However, thin film of polyaminophosphazenes, they are used in hospitals to cover severe burns and other extensive wounds, since they prevent the loss of body fluid and keep the germs out. Thank you so much. See you in the next video.